the models can't do on-the-job training. Human employees, the good thing about them is that, you train them for 6 months or a year, and over time, they're getting better and better. They'll fail, but they'll learn from their failures, and they'll interrogate them in this very organic, deliberative way. This just doesn't happen with an LLM. Why is it not able to do these things right now?
Metacritic Capital says, DWARKESH is out there calling AI hype overblown. I know we stopped doing these things, but likely the AI trade top is in. And he could not have gotten it more wrong. Dylan Tell chimes in.
Fires back.
Yeah. Bro said his taxes by 2028 and all white collar work by 2032. And you think that's a bearish prediction? He just thinks AGI 2027 stuff is wrong. The market isn't pricing either of these scenarios, and I completely agree.
And DWARKESH chimes in and agrees and says the transformative impact I expect from AI over the next decade or two is very far from priced in, and he shares a screenshot. He says, while this makes me bearish on transformative AI in the next few years, it makes me especially bullish on AI over the next decades. When we do solve continuous learning, we'll see a huge discontinuity in the value of the models.
Yep. And
we will get a lot more into this when he joins the show in 20 minutes.
Yeah, so his basic thesis is when you work with someone, they have a set IQ, but they're also capable of continual learning. You teach them and they learn and they adapt, and then they can remember some hard-won lesson from years ago.
Yeah.
I remember talking to somebody, this kind of I don't even know if he's like a philosopher, he's like a user experience designer, and he said that there's multiple ways to learn. You can develop habits through just doing something the same really forcing yourself for a long time. I wake up at 5:30 every morning, wake up at 5:30 every morning for years. Eventually you just wake up at 5:30. But he was like, you can also form a habit by one really, really intense experience. He was like, and the experience and the example he gave was one day he goes out
a true lesson.
True.
Something that you've fully integrated and operate against.
But he gave a great example, which was that he has a river out back of his house, and he goes into the river. And one day he put his foot in his river shoes, like these slip-ons, and there was a lizard in the slipper. And it freaked him out. It gave him this intense response. He was fine. But ever since then, he's been in the habit of always checking the shoe.
There's a snake in my boot.
There's a snake in my boot. Exactly. And so it's not like that was something that had to be trained for years, but it's like this one really sharp, intense learning that then carries forward forever in his life. And so people and employees
do that too. Learn that in school. You got to check your boots.
Check scorpions, your boots for scorpions,
snakes.
But anyway, it begs the question of that is an important thing that employees have and white collar workers have, is this ability to learn hard-won lessons and then carry them forward forever. And we don't even really know how to design against that necessarily. So DWARKESH is saying that there's a lot of work to be done at the research level to figure out continual learning, and that could take a while. He says 7 years from now, 2032, and he kind of goes back 7 years in time. That was GPT-1, which was a saw factory. It was not a good model, but it was an important breakthrough. And so maybe in the next 7 years, something will happen. How are you thinking about just definitions of AGI? And I'd love to actually get a little bit of the history before this piece, your journey, because for me, I grew up watching sci-fi and was like, C-3PO will be around eventually, but it's very abstract and I don't have timelines for that. And then eventually, you start reading,
what's your P-3PO?
You eventually start seeing GPT-3, GPT 3.5, Da Vinci, ChatGPT, and it starts feeling like, okay, we passed the Turing test. We need to really have this conversation about AI. And then PDOOM and AGI becomes like the main discourse for few years.
Right.
But it felt like this piece, even though you and Dylan were going back and forth being like, no, this is still incredibly bullish for the general population.
Yes.
It felt like this was you pushing out timelines a little bit. So walk me through where did you start? When was the nadir of your timelines? When was your timeline it's happening next week, next year?
Yes.
And then walk me through how we got here.
Yeah. So I've got this podcast where I interview people about AI. And I've had on people who have quite aggressive timelines over the last few months. I've interviewed people who are there isn't many people who have written pieces about how we're a couple of years out, right? Leopold Aschenbrenner, AI 2027, recently Scott Alexander and Daniel Cocotello had the AI 2027 scenario forecast, where we've got the bots that can just take over within the next few years. So that's where my head was at as of a couple months ago. And then I recently interviewed these two researchers. I think you actually had one of them on your podcast, Sholto Douglas and Trenton Bricken from Anthropic, about the path forward for RL, which seems to be the pre-training seems to have been giving us these plateauing returns. We make these models bigger. GPT 4.5 didn't seem to be all that impressive. They had to deprecate it. But the path forward does seem to be like O3 actually is very impressive. So that was more the result of this RL process. So maybe now actually, even though pre-training doesn't seem to be as powerful as we might have anticipated, this RL is even more powerful. And so we should accelerate our timelines. And so that's where my head was at as of a couple months ago. But then in having that conversation and thinking through, okay, what specific capabilities in terms of actual applications I, as a small business owner, have, or as a podcast producer have, will AI be able to do? And thinking about, like, why is it not able to do these things right now? And what is the key bottleneck? I realize there's actually no obvious way in which you can either get LLMs to solve these problems for you, or there's no key algorithm, there's no easy, like, prompt injection kind of thing which would help solve these problems. And the key problem I see is the models can't do on-the-job training. So if you think about a human employee, you might have some, and these human employees, the good thing about them is that you train them for 6 months or a year, and over time they're getting better and better. They're learning about all the context and intricacies of your workflow, what you like. They'll fail, but they'll learn from their failures. They'll interrogate them in this, like, very organic, deliberative way. They'll pick up small efficiencies and improvements as they practice a task. This just doesn't happen with an LLM. Every session, you're getting this amnesiac mind that's very smart, but it's lost all awareness of how you like things done, how your business works, and so forth.
And if you had just to put that into context, if you had a incredibly intelligent employee that could not take feedback, you would fire them within about a month, right? Because no matter how smart you are, like, you're not necessarily going to predict every single possible edge case in the work that needs to be done. And then when you make a mistake, if you're not able to, like, sort of update yourself, then what are we even doing here, right? Like that's like learning from mistakes is, like, kind of high on the list in terms of how to become great at any specific task or initiative.
100%. And so then people will say, well, look, maybe the way they can learn from their mistakes, Jordy, is like, you can just tell it in the context, hey, you fucked up this way last time you were working for me. Don't do it again. But I think this is at least an order of magnitude less efficient and less capable than the way humans learn. So the example I use here is, imagine if you were trying to teach a kid to play the saxophone. But the way you had to teach this is, a kid comes into the room and they, like, try to play it cold, right? They've never seen a saxophone before. They try to play a saxophone. And obviously it's not going to sound great the first time. But what you do is then, like, after they failed, you just send them out of the room. You call the next kid who's waiting outside of the room in, and you say, look, here's some notes I wrote down from last time about what the other kid fucked up. Why don't you read that? And you try to play Charlie Parker Calls. It just wouldn't work, right? And this, like, tacit knowledge that you build up through practice is not this, like, written instruction manual that you can just write out as a system prompt.
Yeah. And so our current solution is to RL on saxophone playing specifically for that child, and then in that scenario, you're basically getting that kid drilling that. But my question is, like, it feels like when we think about that in the abstract, it's like, oh yeah, like, work is just, like, doing emails, so let's RL on emails, and then it's doing calendar, so let's RL on that. And so, well, yeah, we'll just chip down at these and, like, book a flight, and then, schedule a call, and then do an outbound sales thing. But really, jobs are not just 5 things to RL on. Maybe it's 500 things or thousands of things. And so maybe the shape of those, like even if we can define a verifiable reward and drill it, it's just there's so many different random things to do that it's going to take us a long time. Is that a reasonable like philosophy?
That I think is part of it, but I think the bigger problem is not just the width or the width of the pool, how many different tasks you have to do RL on, but it's the depth in the sense that a job doesn't involve doing 1,000 different 5-minute tasks individually. It's the fact that you're like trying to work on something, but then somebody Slack messages you something more urgent, and then you have to decide which one is more important. You're like, you got to keep track of this client and what problem they had. By the way, I'm talking technically about what a job might involve because I've never actually worked a real job. So just like how all these things fit together is, we already have these language models that can do like 5-minute language jobs, right? And then the question is, why can't we just delegate all language work? For example, I have these LLMs. I try to get these to rewrite auto-generated transcripts for me, so they're rewritten like a human. I try to get them to just ingest the transcript and suggest clips to tweet out and things like that. And I haven't been able to automate these things. I don't know if you guys have been able to, but it's just like I still have to do it, or I have to get a human to do it. Because, and it's not because we haven't, you might think about like emails or something we got to get like future data on, but this language stuff, we already have the data on, right? So like, why can't we do it now? And the reason is, they can do like a 5 out of 10 job out of the box. These are short horizon, language in, language out tasks, dead center in their repertoire. But there's no way to get them to improve. So over time, you can't be like, look, that tweet was fire, like it went viral, and here's why I think it went viral. And like kind of learns that and like updates its like sort of understanding and writes better tweets in the future. Same with transcripts, picking up your feedback. Since there's no way to do that, even if you have all these individual tasks, like we have all these individual language tasks these models can do, but you can't then just be like, okay, now you're an employee, because an employee is actually improving over time and building up context in a way these models are not.
Yeah.
The big question I've kept bringing up and asking a bunch of different people is, where are you getting value from agents? And not a lot of people have great answers. They'll be like, oh, well, we use this or we use that, but you don't see a lot of conversation online of people like, oh, this SDR is just crushing it for this, like AI SDR is crushing it for me, or this other use case is crushing it. You just don't see that at all. And the reason that that's worrying is that when products are truly great, or even have the potential to be great, or starting to like really work, people just talk about them a lot, right? Like people talk about Cursor a lot, right? People talk about Claude Code a lot. And there's some individual use cases, like coding agents seem to have the most real traction.
Deep research, I would also call like an agent. I don't know if you would put it in that bucket, but it feels.
But again, it's pure.
Yeah.
Again, it's not like this like highly agentic.
Yeah, but I don't think of
workflow.
deep research as like an employee in that same sense. It's not like replacing.
Right, because
like
you can't be
worker.
like, okay, that's great. This thing you put together.
Yeah.
Here's how I like to compile my ideas before a podcast. So, you did a great job compiling this like Stalin memo.
Yep.
I was very curious, especially about these, why the Great Terror happened in this way, and keep that in mind when you're doing a future memo, like this style. That's not going to happen. It's got the style that it's learned through its RL training for deep research. So then again, it just becomes another tool. It doesn't really, it doesn't become like an employee for you.
Can you
and then the other thing, just since your post was inspired, by your own tinkering, some of the stuff that I'm most excited about that we've gotten value specifically from CodeGen internally is just these internal tools that we totally could have built years ago that are just now really fast to build. So we built something for our ad partners that like automatically finds all the different moments that we talk about them in a given show, and then just like links it out. And it's basically just a simple database dashboard that they have access to, that like historically you could have built, but it just would have been like really time intensive. And so it's not anything. It's the value is that you can now build it like in a couple days.
This is CodeGen.
And so I've been trying to separate, like all of this is happening in the context of you have hundreds of billions of like enterprise value locked up in these different labs, some of which have developed what look like great businesses, right? OpenAI, consumer, basically a new consumer app company, Anthropic with cogen, and then there's still like hundreds of billions of value of like EV out there where it's unclear where the revenue is going to come from. And so when timelines extend and AGI isn't happening, next year or the following year or whatever, I start to get generally a little bit worried, because that's a lot of EV to kind of maintain for another half a decade or a decade, whatever it turns into.
I'll get a little more bullish and hypey and take the other side of that. Take the other side of your claim. Look, I think even if it doesn't happen in the next 2 to 3 years, what we're talking about here is such a big deal that AI is definitely not priced in, not by the average person, not by the market, by anything. Because once you get this thing which actually does function like a genuine white collar employee, not only do you have potentially billions of extra workers, but you have something potentially more powerful, which is that right now, a human mind can't be copied, right? A human mind can't learn from the experience of other minds. If we have a model
Or it
that
can,
is
but
capable,
it's really slow. Like you have to
Yes,
basically work with
exactly.
somebody for a decade, and then you
mentor.
can. Yeah, it's mentorship.
Yeah, exactly. Yeah. And in fact, it's been a big problem because as our society has built up more knowledge, we had to keep people in school and training for longer and longer, which reduces their productive years. But with an AI model, you could have a scenario where suppose there is a model that's actually capable now of continue learning the way humans can learn. Not only would it, so, it's broadly deployed through the economy, it's doing all these different jobs. The difference is that it is now able to amalgamate its learnings across all its deployments. So if one of them is an accountant and one of them is a coder and whatever, the model is learning from each of these different on-the-job experiences. And then, so even if there's no software progress out of that point, that algorithms aren't improving, just that ability to learn on the job from everything in the economy would functionally produce what looks like a super intelligence, right? No human will have mastered the range of skills and knowledge and know-how that this model will have.
Yeah, that makes sense.
I have 2 questions. One's kind of maybe bearish, one's bullish. On the question of just, is it possible, you think, to brute force continual learning by just doing something on the design of these models side, or maybe in the hardware side, to just get to a trillion token context window and then just stuffing it with everything? Can you explain kind of what the state of the art is here? Because you were mentioning in the piece, like the cursor roll-ups, the summary lines, and then stuff getting lost in there. But if we get to 100 billion token context window or something, could it actually just remember every single interaction it's had?
I am not optimistic about that because we've had, since 2018, we've had the transformer or alterations on the transformer as being the most performant models. And, who knows what the labs are doing, but we do have open source research from companies like DeepSeek, which does seem to be at the frontier or close to the frontier. And while people have found modifications to the transformer, which make the constant time overhead of attention, to reduce the constant time overhead on attention to, like, you find these little hacks with mixture of experts or latent attention, nobody has gotten around the inherent quadratic nature of attention. And basically this means that the cost of the additional token increases super linearly to just that additional token. So right now we have models that have 1 million tokens or 2 million tokens of context, but getting it to 4 million tokens is more than twice as much compute.
Got it.
It's significantly more than that. And then just taking it to like 1 billion, it just, given the fact that nothing about this has changed over the last, 6 years, I'm just like not optimistic that somebody will figure out a hack that will change it immediately.
Then on the side of, like, how do you think about continual learning in domains where time is, I keep going back to this idea that, like, even if we create the ultimate super intelligence, like, it probably will have to obey the laws of physics, won't be able to time travel or teleport. And so there's a lot of restrictions on that. Like, at a certain point, you just need to move the sand into the chip fab. And then there's a certain amount of energy and time that it takes to do that. Another example would be like longevity research. Some of that you just need to sit around and wait for a human to age. And so your RL cycles, if you're trying to learn about how humans age, it's very hard. Yeah, you can like simulate the human or whatever, but like for the real test, you have to wait decades to see the effect of a certain diet on how long people live. And so it feels like there's a lot of scenarios where you can't fully do it simulated, and so you wind up with these really long times to actually do a rollout, essentially. And
Yeah.
you wind up with something where the time to actually get a new data point or new training data is like 1,000 times longer than what we've been doing previously. And so we're in this data desert, basically.
Yeah, I think this will definitely be true of many domains, especially those involving the physical world. I guess as I've learned slightly more about some of these physical domains, it's been surprising to me how much can be done in simulation. Within bio, for example, obviously we AlphaFold and I guess now AlphaGenome, but even one of the key advances in bio over the last couple of decades has been techniques of multiplex experiments, just running millions of experiments in parallel, getting data points from that past, using AI to learn from millions of seemingly experiments in different fields about like what that might imply for the human body or for human proteins. So I am like optimistic. Another thing to keep in mind is that right now, a corporation might have 100,000 employees, but how much is learning from any single employee is very limited. People are just go in, do their jobs, and that's that. In the future, if you do have this economy of agents, and it's much easier for AIs to supervise each other, to be observing every single thing that's happening in the organization, the speed of learning might be exponentially faster than what's possible with humans. I agree this is like not around the corner, but the sort of singularitarian futures with crazy cyborg organizations that are moving super fast and coming up with new technologies doesn't sound crazy to me.
Interesting. What do you think the recent, like last week was dominated by the talent wars and the huge AI researcher offers at Meta? What do you think that reveals about Mark Zuckerberg's AGI timelines?
By the way, I loved all the memes, the traded memes. Honestly, you should lean into that because like genuinely, this is not even a meme. This is like genuine. The market cap should move by billions of dollars based on these posts you guys are doing.
Totally. Yeah, it was crazy seeing like 10 million views on an AI researcher getting traded. Like it's niche, but it's not really that niche anymore.
Right.
But I don't think you could have imagined. You certainly couldn't have fully imagined that 5 years ago.
No way.
Even.
No way. Yeah, it's important stuff.
I mean, I still think they're like underpaying them. I think like Meta's the first company that is actually coming close to the break-even point of
the value
what the best AI researchers are actually worth the company. If you're Meta and you're spending $80 billion on compute over the next couple of years, if one great researcher can give you a 1% performance uptick on that, they're like so worth the $100 million PayPal. You're getting a bargain at $100 million. So it's actually interesting to me that Meta is the first company that's like, wait, the return on investment here is incredible. Let's just do it. And then, okay, are the vibes bad? Maybe could they have done the announcements better to produce better, less mercenary vibes potentially? But so there's like some ideal version of what they could have done. But also keep in mind that the likely counterfactual would not have been that amazing, great vibes announcement. The likely counterfactual would have been what they're previously doing, which is just like sleepwalking towards loss. And it's much better to just like, fuck it, let's just send it with a couple $2 billion in recruitment offers. And like, at least now they're on the player board rather than just like sleepwalking towards Armageddon.